If you're a Delphi developer building for Android, you already know the dream, right? A single code base, a beautiful UI, and that buttery smooth native level performance. But let's be honest, getting that last part, that critical feeling of fluidity, can be a huge challenge. In this explainer, we're going to break down a modern playbook to take your FireMonkey apps from laggy to lightning fast. Let's get into it. Does this sound a little too familiar? This quote from the Australian Delphi user group forums just nails a frustration that so many of us in the community have felt. It's that nagging feeling that no matter how clean your code is, the final app it doesn't feel truly native. It's a pain point we all get. But the good news is, it's a problem we can absolutely solve. So here's our game plan. We'll start by looking at the core challenge. Then we'll dive straight into 4 key pillars for a fix: revolutionizing your rendering with something called Skia, unblocking the user interface, mastering mobile memory, and finally, the golden rule: measure your results. First things first, let's get right to the heart of it. Why do our FireMonkey apps on Android sometimes feel, sluggish? Understanding the why is really the first big step to fixing it for good. A laggy interface isn't just some minor annoyance. In today's app stores, performance is a feature. A smooth, responsive app keeps people happy and makes them trust your product. A slow one, well, that gets uninstalled. It really is that simple. So what's the technical culprit here? 9 times out of 10, it's the Android main thread, which you'll also hear called the UI thread. I want you to think of it like a single-lane highway. Every single UI update, every animation, every button tap, it all has to travel down this one lane. So what happens if you put a slow-moving truck, like a heavy database query or a big network request, on that highway? Everything grinds to a halt. If you block it for more than about 5 seconds, Android throws up that infamous application not responding dialog that we all hate to see. All right, let's get to our first solution. And honestly, this is probably the most impactful one. If you only do one thing after watching this should be it. We're talking about completely replacing FireMonkey's default rendering engine with Skia. And the difference is, well, it's night and day. The default FireMonkey renderer on mobile often skips anti-aliasing, which can make your graphics look kind of jagged. It can also be inconsistent with how it draws things like strokes and corners. Skia, on the other hand, is this mature, GPU-accelerated graphics library. It's actually what Google Chrome and Android itself use, and it gives you gorgeous, high-quality anti-aliasing right out of the box. It fixes all those drawing issues, which leads to an app that not only performs better, but looks way better too. And hey, this isn't just a theory. We've got the data to back it up. Check out these benchmarks from the Skia for Delphi project. This is a real-world app with hundreds of controls. Look at these numbers. On an LG K40S, it jumps from 30 to 47 frames per second. On a Moto G3, from 25 to 38. That is a massive, tangible improvement in smoothness that your users will feel instantly. The scale of improvement here is just huge. When you combine a powerful rendering engine like Skia with other modern Android tricks like baseline profiles, you're looking at a potential code execution speed boost of 30 to 50%, right from the very first time the user launches your app. That's a total transformation of the user experience. Okay, so our rendering is blazing fast now, but we need to make sure our own code doesn't become that slow-moving truck on our main thread highway, and this is all about concurrency. And Delphi gives us the perfect tool for the job, the Parallel Programming Library, or PPL for short. This is your absolute best weapon for sending all those heavy tasks, like network requests or processing files, off to background threads. This frees up the main thread to do what it does best: keep your UI incredibly smooth and responsive. Now, the PPL can seem a little complex at first, but it really just boils down to a few core ideas. An iTask is your go-to for just running some code in the background. Think of it as fire and forget. An iFeature is similar, but it's designed to give you a value back when it's done. Perfect for offloading a big calculation. And tparallel.4 is just unbelievably powerful for taking a massive loop and automatically splitting the work across all the available CPU cores. And getting started is as simple as this 3-step process. First, find an operation that's blocking your UI. You know the one. Second, just wrap that code in a ttask.run call. That's it. It immediately pushes it to a background thread. Third, and this part is absolutely critical, once the task is finished, you have to use something like tthread.q to safely pass the results back to the main thread so you can update your UI. Okay, our rendering is fast, our UI thread is clear. The next major bottleneck, especially on mobile devices, is memory. So let's talk about how to master it. In the world of FireMonkey mobile apps, there are 2 main culprits that cause most of the memory and performance headaches:
The first, and by far the biggest, is bitmaps. Loading a full-size multi-megapixel photo from the camera just to show a tiny little thumbnail, that's a recipe for an out-of-memory error. The second is creating way too many controls at runtime, which can slow your layout and painting to an absolute crawl.
So, here's your toolkit to fight back. For bitmaps, the rule is simple. Never load the full resolution image into memory if you don't need to. Always load a downscaled version that's the right size for where it's being displayed. For those really complex layouts, instead of creating thousands of labels and shapes, use a single T-Paint box component and just draw your UI yourself. It is orders of magnitude faster. I'm not kidding. And that's not just a friendly suggestion. As one expert on Stack Overflow put it very bluntly to a developer trying to create 2,600 controls at runtime, you'll just never get acceptable speed that way on mobile. For complex, data-heavy UIs, custom painting isn't just a nice-to-have optimization, it's an absolute necessity. And that brings us to our final pillar, the one that really ties everything else together. See, optimization isn't about guesswork. It's an engineering discipline. You have to measure. This right here is the mindset shift that separates the pros from the amateurs. An expert doesn't just guess where the code might be slow. They treat optimization as a cycle. You measure to find the real bottleneck, you implement a fix, and then you measure again to prove it actually worked. You simply cannot optimize what you don't measure. And the great news is we have powerful tools to do this. For your Delphi code, you've got things like the Alpacino Code Profiler. For really deep industrial-level analysis, there's a QTime. And don't ever forget the free Android Studio Profiler. It's the gold standard for seeing exactly what your app is doing on a device, from CPU cycles down to every memory allocation. So let's recap the playbook. Number 1, adopt Skia for a huge foundational boost in rendering speed and quality. Number 2, use the parallel programming library to offload all the heavy lifting from your main thread. 3, be ruthless about memory, especially with bitmaps and complex layouts. And finally, number 4, profile everything. Make your decisions based on data, not guesses. Which brings us right back to where we started. That feeling that going cross-platform always means you have to compromise on performance. But with a modern playbook that uses these 4 pillars, we have to ask, is that still true? Or can a well-optimized Delphi app finally deliver a truly native experience on Android? The tools and the techniques are all here. Now it's time to build.